last couple of videos I've been doing a number grid and how it relates to sort of all these other well-known and lesser-known number patterns, but basically talking about dimensions. And sort of I've been starting off, so we have the first dimension, and a way to think of that is like a train or a tightrope walker. He can go back and forth, but he can't move up or down or closer to us. And then you have the second dimension, and then you might think of a TV cartoon character. So someone's on the screen, and again now they can move side to side, and they can move up and down. They have two spatial dimensions to move within. So that's the one way to think about the second dimension. We have the third dimension, and it's and we've got cube. So now, if you've ever done an animation, seen a CAD, now we have three directions of movement. So backwards and forwards, up and down, and anyway, so it would be like Cartesian coordinates if you follow me. So 1, 2, and 3 dimensions. So that's like one way to think of it. But then we have the maths of it. So we're going to moving across the first dimension. So 1 to the first, 2 to the first, 3 to the first, 4 to the first, and so we'd have 1 to the second dimension and 1 to the third dimension. It's another way to think of these powers squared. Like if you measure the edge, how long one wall of a room is, you're measuring along one dimension. The ruler's going back and forth in one dimension, but when you measure carpet or how much paint you need, you're measuring in 2 dimensions, up and down and side to side. That's like another practical. I think we lose it a bit now. I talked about the way they sort of work together, and if we add these 3 numbers, we'll get the answer there. So 2 plus 1 plus 1 is 4. I've gone, anyway, if someone hasn't seen this, maybe the same pattern. If we add these 3 numbers, we get the answer there, which is 9, and 9 plus 3 plus 4 is 16, which is 1 squared, 2 squared, 3 squared, and 4 squared. So we have the second dimensional numbers and lines. And so we have, and you can do it on a spreadsheet and test it if you're that way inclined, and you see it goes on forever and ever. It's just a different way of thinking of something called binomial theorem. We've sort of learned it at school, but you lose the magic of it by then. And so we have how one dimension and the second dimension there's a little pattern going on there. In a couple of videos back, I'll point it out, and then if we try to do the same thing here, so 1 is 1 plus 4 plus 1 is 6. And the number we're looking for is 2 cubed, 2 times 2 times. So we want the number 8, but when we add these 3, we don't get the same pattern going on. What we have is a deficit of 2, so we're minus 2, and 3 cubed would be 27. If we add these 3, we get 21, which is 6 short, and this would be 64, 4 cubed, 4 times 4 times 4, and if we add again, that's 52, and we're 12 short. But what you might notice is that so we're first and second column, 1 times 2 is 2. 2 times 3 is 6. 3 times 4 is 12. So what you're going to find is the gap, the key, the bridge, whatever, the differential is always going to be defined by the first dimension. So to find the key to the third dimension from the second, you need to multiply the first. If you yeah, now here's a interesting, here's where I'm intending to go through. Talked about triangular numbers at the beginning, and what in the first, so 1 plus 2 plus 3 plus 4 is 10, but that's a triangular number, but also sort of famous through the Pythagorean school. But 1 plus 2 plus 3 plus 4 equals 10. That's the first dimension. Now another pattern you'll see repeated is, so 1 plus 8 plus 27 plus 64, which is well, that equals 100. Okay, so if we add the three-dimensional line, we get 100. 10 squared, yeah, okay, equals 10 squared, or the square root of 100. So what's just, I'll write it out again, 1 1 plus 2 plus 3 plus 4 equals 10. Put 1 to the third plus 2 to the third plus 3 to the third plus 4 to the third equals 100, which is the square of that, or the square root of going the other way. So we can, and it's not just a fluke to these particular rows, it's a pattern that will continue out. And as an example, 1 to the first plus 2 to the first plus 3 to the first is 6. 1 to the third plus 2 to the third plus 3 to the third is 36, just double check, which is 6 squared, or the square root of 6. So it's not just do I have to make some room, but another way to, curious thing that happens is that if we basically do the same thing, but we're going to multiply, and we'll start with just the first three. So 1 times 2 equals 6, but 1 to the third times 2 to the third times 3 to the third. So instead of addition, as in over here, we're multiplying, and we get 216, which is 6 cubed, or the mark of the beast, 6 times 6 times 6. But also a very famous number with harmonics and Pythagorean schools, astronomy, and other bits and pieces. Yeah, okay. Where am I along? Already at 9 minutes. Okay. So yeah, just to follow on. Talking about the first dimension, second dimension, and third, and how they work together, and just some really simple classical arithmetic. There's some nice correlations, connections between the dimensions, Pythagorean schools, harmonic numbers, and triangular / tetractys numbers.